Good morning to my dear judges. I am Devasrapal of class 9 and I belong to section A. Today we are here to explain and to prove the formulas of the curved surface area and volume of solids. My guide teacher is Sir Saurabh and today she is my group member.
Hello judges, I am Dipanjali Das of class 9. I am group member.
So let's start. Like in case of this, it is a cuboid, yes. Now it contains how many faces? It contains, let us see how many faces. 1, 2, 3, 4, 5 and 6. That means 6 faces. How many vertices? 1, 2, 3, 4, 5, 6, 7 and 8. That means 8 vertices. How many edges? 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11, then 12. That means 12 edges. So now let us find the volume. So at first we have to know what is the meaning of volume. Volume is the space occupied in any object. So since we know that it contains 6 faces, so now we can tell what will be its total surface area. Total surface area means the area of the total surfaces. And how many surfaces did it have? It has 6 faces, that means 6 surfaces. So if we find the area of the 6 faces, that means we are going to find the total surface area. So in this case, let us take this is the length, this is the breadth, this is the height. So now let us find the area of this surface, then this surface, then this surface, again this surface and this and this. So now let us find, this is length into breadth, this is length into height, this is breadth into height. Again, this is equal to this, it is also breadth into height, and this also equal to this, that is, it is also length into height, and this also equal to this, that is, it is length into breadth. So now we can tell length into breadth plus again length into breadth plus again length into height plus again length into height plus breadth into height plus breadth into height, we can tell is total surface area. That means it will be 2 into length height plus 2 into breadth height plus 2 into length into breadth. So it is the formula of total surface area. So now in case of curved surface area, if we remove this upper surface from total surface minus upper surface area minus bottom surface area, yes, that means we are going to find the area of this surface. What is the meaning of lateral? Lateral means side. That means we are going to find the area of this sides only, this sides. Okay, so let us find, this is the length, this is the height, this is the breadth and this is the height. So we can tell 2 into length into height. Why? Because these and these are same, these and these are same. Again 2 into breadth into height, because these and these are same. The areas are same, the breadth and height are also same. So we can tell 2 into length into height plus 2 into breadth into height. So it is the lateral surface area of cuboid. Now we are going to find the volume. So now let's find. What is the volume? As I told before, the volume is the space occupied in any object. So in this case, what is the space occupied? This space is said to be as the volume of the cuboid. So let's take, this is a piece of paper. Let us take, this is a piece of paper and its height is very small. Let us take 0.0000, very small. Okay, 0.0002 millimeter like this. Okay, then what we can tell? Up to how much we can add, and this height of the cuboid will be formed. Is said to be as the height of that total of the height of that cuboid. So now in case of this, if the height is very small of each piece of paper, then how much is the amount we can take in the cuboid? It will be more. If the height of each is small, then the height will be, the amount of things present in that cuboid will be less. Yes? Then we can tell the height of this is always influenced by the height of this cuboid. Yes. So now we can tell length into breadth into height. For this reason, it is given length into breadth into height. Because volume means the space occupied in any object. And this space is always influenced by the height of each piece of paper. For this reason, we can't find the actual amount. It may be millions, billions, trillions, maybe. But we can find how much it is the volume. That is length into breadth into height. And since we have to make our technology more advanced, then we have to do various types of work. And to do various types of work, we have to know various things. We have to know the volume, we have to know the surface area, we have to know the various types of things in maths. For this reason, scientists developed these formulas. And And now we are going to find the diagonal of the cuboid. Why the diagonal is root over length square plus breadth square plus height square? Why it is like that? The main thing is that, let us take, this is the diagonal. This is the diagonal. From that point to that point, it is the diagonal. And if you append this diagonal, what is this? This is a right angle triangle. Each angle is 90 degree. So in this case, we know that it is the diagonal of the cuboid, and it is the height, and it is the base. So we can tell, according to Pythagoras theorem of right angle triangle, we can tell hypotenuse square is equal to the base square plus height square. So now the hypotenuse square, it is nothing but the diagonal square. So we can tell the diagonal square is equal to base square plus height square. That means diagonal is equal to root over base square plus height square. If we put again here, then what we can see? If we see more deeply, then this is also a side of the cuboid, and it is a rectangular shape. So now we can see this base is said to be again the hypotenuse. Then we can tell this base square is equal to length square plus breadth square. So for this reason, this hypotenuse square is equal to length square plus breadth square. So we can tell that diagonal square is equal to length square plus breadth square. We found out length square plus breadth square, and this is the height square. Then diagonal is equal to what? Root over length square plus breadth square plus height square. So it is the proof of this. So cuboid finished. Now in case of cube, we know that a cube is also a form of cuboid. It is also a type of cuboid. It contains all the sides equal. This is a cube. So it contains all these sides of equal. Let us take the side, the length of each side be A. Let us take this is also A, this is also A, this is also A, and this is also A. So for all this, the length of the sides will be what? A. So in this case, if we find the area of this surface, then we can find the area of the full surface, because the area, this is A square, because A into A, it is a square, no? So it is A into A square. So in case of other surfaces, the other surfaces also have same length on the same side, same length. So we can tell other surfaces also will have A square. So since it contains 6 surfaces, 6 faces, so we can tell 6 S square, 6 times S square, that is 6 S square. Now we are going to find the lateral surface area. We know that lateral surface area means total surface area minus the area of the upper surface and the lower surface. Then that means we can find the lateral surface area will be 4S square. Why? Because it contains 4 faces, 1, 2, 3 and 4. That is 4 faces. So it is 4S square. So it is proof. Now in case of volume, as we know that volume means the space occupied in any object. So the volume will be 1. According to cuboid, we found it is length into breadth into height, and we know that cube is also a type of cuboid. So we can also tell length into breadth into height. So in this case, length, breadth, height are all same, and we took it as A. So we can tell A into A into A. So we can tell A cube. That is, it is the volume of cuboid. A cube. Volume of cube, not cuboid. Volume of cube is A cube. Now if we want to find the diagonal of cube, then what we can say? Like in case of diagonal of cuboid, we saw the diagonal is equal to root over length square plus breadth square plus height square. So in case of cube, what we can tell? It will be root over length square plus breadth square plus height square, and we know that length, breadth, height are all same. That means root over S square plus again A square. So we can tell root over 3A square, and root over 3A square means root over 3 into root over A square, that means root over 3 into A. It is the diagonal of the cube. So this also proves. Now in case of cylinder, this is a cylinder, this is a cylinder. Now in case of this, like if we cut the cylinder from the middle, then what we can see? It will form a rectangular shape of a paper, like a paper only it will form. It contains what? Length, it contains breadth. So when we will again roll it, then it will form like this shape. So we can tell this breadth will be this one, that is the circumference, which is for circumference we know that circumference of the circle is 2 pi r. Okay, so it will be 2 pi r, and we know that length is said to be as the height for the cylinder. So we can tell 2 pi r, because we know that in case of rectangle, its area is length into breadth. So in case of cylinder also it will be same, length into breadth, and breadth is nothing but it is the circumference of the circle. So this 2 pi r, and length will be converted to h. So this 2 pi r h. It is the curved surface area of that cylinder. Now if we want to find the total surface area, that means curved surface area plus this surface is said to be as what? The total surface area, that means area of the two circles is said to be as the total surface area. Then curved surface plus area of the two circles. So we know that curved surface is 2 pi r each, and we know that the area of circle is what? Pi r square. And another circle, same radius, it will also be pi r square. So in this case, pi r square plus again pi r square is said to be 2 pi r square plus curved surface is 2 pi r each. For this reason, pi is 2 pi r square plus 2 pi r each. If you factorize, then the answer will be 2 pi r into pi r plus r. It will be the answer. So for this reason, the total surface area is this one. So now in case of volume, if you want to find the volume of cylinder, let us find not this one. Like in this case, we know that it is pi r square. It is the age. So we know that how much we can keep, that height, how much we can keep is said to be as the volume. So we can't find the actual amount, but we can find the volume is said to be as, we know that area of base into height. So area of base is pi r square into h. For this reason, it is pi r square h. Now if you want to find the cone, it is a cone. So in this case, it is the base of the cone and is the curved surface area of the cone. So now if we cut that cone, then what will be formed? Like this shape. It will be formed like this shape. So now if we want to find and to see it is a cone or not, let us see. If we roll it like that, then it will be in a conical shape. It will be in conical shape. So if we find and if we cut it from the middle, then we can get this one. If we find the area of this surface, then we are going to find the curved surface area of the cone. So now in case of curved surface, let us put this one in that part. And we know that in case of cone, like this is a cone, in case of cone, the stand height is this one. And this is said to be as L. So in this case, this is also will be L. And what will be this one? Let us again take this one as cone. What will be this one? This will be 2 pi r because we took the radius as r. So it will be 2 pi r. Okay. So in this case, it will be 2 pi r. So now in this case, this is 2 pi r and this is L. And if we put this in that circle, then what will you see? This is a part of the circle. And this length, which is this stand height, that means this stand height will be always equal to that stand height. This stand height will be always equal to that stand height. And this stand height, let us take as the radius of the full circle. So we can tell the circumference of full circle will be 2 pi l. And we know that in this case also 2 pi r. So we can tell this area will be how much the area of that circle. So now let's find how much it is. So we know that the area will be less than this circle. Why? Because it is a part of the circle. So we know that to make any number small, we have to always take the numerator. The numerator should be always small, then the denominator. Let us take an example like 2 by 4 is equal to 1 by 2. This is a small number. Like if we take 4 by 2, that means numerator is bigger. It will be 2. Okay. So in this case, the 2 pi r is small and 2 pi l is bigger. Then 2 pi r by 2 pi l. And what is the area of this full circle? We know that we took the radius as L here. So we can tell the area of full circle will be pi l square. So we can take pi l square into 2 pi r by 2 pi l. Then we can get what will be the circle, this area. That means CSA will be what? Pi r l. If we cut it, then we can say it is pi r l. So curved surface area will be pi r l. And again, we got the curved surface area. Now in case of radius, let us take this one as radius. Then what we can tell, it is a pi r square. Then pi r square plus pi r l is the total surface area. If we put this one in that part, so we can see that in this case the pink color line is the stand height and this is the radius, the violet color one is radius. And if we open it, then what we can see, this pink color is the stand height and this yellow is the height and this violet color is the radius. So it is a this is a right angle triangle. So in case of Pythagoras theorem, we know that hypotenuse square, that is stand height square, is equal to base square plus height square. And base is nothing but the radius of the circle. So r square plus h square. So we can tell that L is equal to root over r square plus h square. So we found it. Then say when we want to find the volume of the cone, we have to probe. Let's find. Let us take this one. We took in that volume of that spoon we took water at one time only. Then again we are taking that water again. Then again we are putting. Again let us take water. Let us see what happens. We can see that full volume came. That means if we take 3 into the volume of cone is equal to what? Pi r square h in case of volume of cylinder. So pi r square h. So 3 into volume of cone is said to be as pi r square h. That means volume of cone is equal to pi r square h by 3. That is 1/3 of the volume of cylinder. So it is proved. So now in case of hollow cylinder, it is a hollow cylinder. Okay. So in this case, if you want, let us take this full as the red R and this small is the small r, that is R. Okay. Let us take the full as the bigger radius as capital R and this take as small r. Okay. So now we can tell that volume will be, we know that in case of a cylinder, pi r square h, and this h is same for that cylinder. So pi r square h, that is pi into r is capital R square h minus pi into small r square h. So we can tell pi into h, then in bracket capital R square minus small r square. So it is the volume of the hollow cylinder. So after that much was only our proof, and we proved the whole surface, total surface area and curved surface area and volume of the solids.